Hello and welcome. You're listening to episode number 50 of the podcast at the Crossroads of the Safe Network. I'm your host, John Ferguson, the simpleton of Project Safe, because not everybody can be a geek. But that doesn't mean we can't each have an understanding of what's going on, at least from a high level. And that's what I try and bring to the table, because, I can't get down to the metal without getting too confused. But at a high level, this is important stuff because we're talking about the SAFE network here, where SAFE, S-A-F-E, stands for Secure Access for Everyone, with privacy, security, and freedom designed in from the ground up. It's an open source, full disclosure project headed up by MaidSafe, which, when the network is finally let loose in the wild, the MaidSafe is just going to be one among equals, probably first among equals, I must say, because they'll know it top to bottom, but they'll be contributing along with others in this really first truly autonomous data storage and communication network with no servers, no middlemen. It's been in development for a long time, and it's coming down the pike. If you're not familiar with the different parts of the SAFE network and you want to get the big picture, a great place to start is to go to safenetwork.tech. Then if you want to find about MaidSafe, the company, go to MaidSafe.net. All right. So this episode, we're going to cover a recent advance on the integration of mobile apps for the SAFE network. And to help us all kind of understand more about it and sort things out, what it means and so forth, we have Lionel Faber. He's a front-end developer with MaidSafe office in Chennai in southern India. Welcome, Lionel.
Thank you, John. It's a pleasure to be here.
Yeah, it's great to have you. First of all, if you could tell us a touch about yourself and how you came to be working for MaidSafe, like your qualifications and so forth.
Sure, John. So I'm a very recent graduate from university. I actually graduated only in May 2018. And after graduation, I joined this company where we used to build software as a service web applications. And 3 months into the job, it was okay. It was going. I was actually enjoying myself over there. And then I came across this hackathon, which was organized by MaidSafe. And I didn't think of actually looking for a different job at the point. But then I was up for the challenge. So I said, hey, why not? And I took up the hackathon. And after the hackathon, I was asked to come in for an interview. And I was like, okay, let's see what these guys actually do. And then I looked up what MaidSafe is, what the SAFE network is, and what it does. I was browsing through a few of the videos on YouTube, and I came across this phrase that says privacy, security, and freedom for everyone. I was like, whoa, that's really cool. And one more thing that really interested me about the SAFE network was everything was open source. I've always been an open source enthusiast, even from my college days. So the fact that this was open source was another driving factor for me to switch over. And then I came in for the interviews, and then a couple of weeks later, I joined MaidSafe.
Fabulous, fabulous. Now, you're working in the Chennai office. That was opened a while back. And I don't want to get into too much detail because I actually want to cover that whole satellite project more thoroughly. But what's it like working there? You've got a bunch of developers working out of that office together now, right?
Yes, John. The Chennai office was started January of last year, 2018. And I think we had previously 3 people from India who were working remotely for MaidSafe. And after the office started up, I think I was the first recruit. So I joined the team in May. And now we are up to 14. We have 14 people working in the Chennai office.
Cool. Well, like I say, that you enjoy working closely where you actually get physical connection with people, right?
Yes, it's really good working with people there. And we bounce ideas off each other, have so many discussions about what the network is and what it can do. And it's really, really fun actually working there. A lot of challenges, but still it's fun.
Oh, yeah. Well, MaidSafe has people working remotely all over the world. It's neat to have that center there where people can actually shake hands and talk across the table. Anyway, we're going to go into that in a later episode. Let us kind of get on to the subject here. Native development for Android apps. I guess the first thing to take up here is, first of all, lay the perspective. Why is actually developing mobile apps so important to what we're doing and to the development of the network?
Well, John, as the years have gone by, the number of mobile devices being used today is really, really massive. And more people are getting introduced to the internet. And it's more probable that a person would access the internet first via a mobile device rather desktop devices because they're much more affordable and the connectivity is so much easier. So as people join the internet, they're joining via mobile. And the number of applications that are being built today, they're also growing so much more. So it's really important that we give this extended mobile support so that we can also join the race.
Yeah, this is a massive adoption point. There's some interesting things about this. First of all, there's a lot of development attention on developing decentralized applications. Could you give us your perspective on how the Safe Network relates to other efforts in terms of decentralized networks and how app development for the Safe Network is different than other decentralized networks? Like, the most prominent ones are probably Bitcoin and Ethereum. What's your consideration regarding those things?
So yes, John, as you've mentioned, other decentralized networks do allow you to access from a mobile device. And these are primarily wallet applications where you can manage your cryptocurrencies for those decentralized networks. But what I've noticed is the APIs that some of them provide, they don't communicate with the blockchain directly. So you need to have a system, a computer or a cloud node, which is part of the blockchain. And the API that they provide allows your mobile device to securely communicate with that node. So that node is the intermediary between your mobile device and the blockchain itself. So that is like sort of a server. So whatever you send from a mobile device goes to that particular node. That node is part of the blockchain. It does all the decentralization that's needed, and it sends a response back to your device. So it's not directly connected to the decentralized network.
So essentially that's a single point of failure. It's all through a company who really has some kind of proprietary control over your interface with the network. Is that really the takeaway point there?
Yes, exactly. So everything goes to that one node or those set of nodes. But for the Safe Network, what we have is the APIs that we've provided, they do not go to a particular node or one particular system and then go join the network from there. Your mobile device will directly connect to the decentralized network and all transactions happen to the network directly.
That seems like a pretty big deal. How is it that the Safe Network actually deals with this so that you're not you don't have a central point of capturing the user's information, but the user can still access the network?
So it's the same set of APIs that we're providing, whether it be desktop or mobile. So the important thing here is whether the mobile application is able to authenticate to the network. And here's where the self-authentication steps in. So on the Safe browser, it has the Safe Authenticator, which will enable a user to authenticate himself to the network. So we built a Safe Authenticator proof of concept for mobile too. It was actually built some time back, and a proof of concept was done in the early stages of Alpha 2. But now the APIs have been updated. And so we've updated the Safe Authenticator proof of concept to these latest APIs. So the mobile device will be able to authenticate the user through this Safe Authenticator application, and then all transactions can go directly to the Safe network.
Cool. So that's kind of differentiating between mobile and desktop and so forth and other ways of accessing it. But I tell you what, just for those that aren't familiar with the process, let's just cover quickly what we mean by self-authentication, because that's something unique to this network as far as I know. The whole concept of self-authentication, and then how do you continue accessing the network using that? Could you give us a breakout on self-authentication a little bit?
Sure, John. So by self-authentication, what we mean is when the user authenticates to the network, he's not sending his credentials to the network, and then the network says, okay, I now know who you are and you are authenticated. Now I'm going to allow you to communicate to the network. This doesn't happen on Safe. On the Safe network, the user authenticates himself within his device. And by within the device, I mean within the Safe Authenticator itself. So the user uses his secret and his password. So the user's data is located at an address which is fetched using the secret, and this data is encrypted. So once I get the data from the network, I can use the password to decrypt that data on my local system. So my password does not leave my system. And once the data is decrypted, the network knows that, okay, only I can decrypt my data because only I know the password. And using that data, I can now access the network. So my secret and password never leave my local system.
The one step of understanding there that I would probably throw in is that the user actually establishes that relationship with the network without having to go through anybody else. An account, so to speak, is just something that the user actually establishes directly with the network. It doesn't go through an internet service provider or anybody else who has the yes or no option on that. So it's not something that any third party can shut down. Is that a safe way to say it?
Yes, John, that's a good way to say it. Because the authenticator doesn't communicate to the network in one particular way. So no other third party or no internet service provider will be able to identify that, hey, this kind of data that is being transferred is being done by the safe authenticator. Let's target this and shut it down. They can't do that.
But yeah, I guess my point is you don't have to ask for permission to set up a relationship with the network. You just do it without any third party. And as long as you follow the rules, you have a separate account. So basically, that's the safe access for everyone part of the safe network, right? It starts with
Exactly,
self-authentication.
John. Yes.
Cool. I just wanted to touch on that. People who want to understand more about that, dig into the underlying data, especially like safenetwork.tech lays it out pretty well. Let's look now at how an application uses that to securely deal with the user's data and what control the user has.
Yes, John. So any mobile application too, if you want to access the safe network, all you need to do is the mobile application has to authenticate itself with the safe authenticator. So it will build a request saying, I want to access the network. And this request goes to the safe authenticator. That now asks the user saying, hey, there's an application. This is its name. It's being built by this organization. Do you want to allow this application to access the network? And the user has the option there within the authenticator to allow or deny this application. So once this is done, the authenticator sends back a response to the application and say, okay, the user has said you can now access the network. And using this authentication response, it can now access the data on the network.
Cool. Now, I guess one thing, a question that I think people are going to have there is, how is that different from any user agreement? In other words, you're authorizing different applications to do things for you, but how do you know that? What additional security is there in the relationship the user has on the safe network as opposed to others? In other words, can an app start accessing other data or sending it elsewhere? That's really kind of important because the difference that I see is because other applications require, like a wallet app on Bitcoin or Ethereum and so forth, requires its own set of servers to access the decentralized network. So there's nobody in the middle regarding the safe network. But I guess it's a part of breaking that thinking apart. Well, the application now has, how do you trust it that it's not doing something that you don't want it to do?
Well, technically, the application, even if it tries, it cannot do something the user doesn't want it to do. Because what happens when a request goes to the authenticator, the application says, hey, I want to access this particular data on the network. And the authenticator asks the user says, okay, he can access it. So what the authenticator does is, in a way, it tells the data at that location, says, hey, there's an application that has requested for permissions, and the user has said, okay. So you can now expect the application to come in. So when the response that is sent from the authenticator to the application doesn't have any token as such, that, okay, the user goes and says, hey, I got this token. Using this token, he doesn't access the data. When the application tries to access the data already knows that this application is going to come because the authenticator has told him so. So that's how the data is being accessed by the application and not through the token that it received from the authenticator.
I think I follow that. And I don't want to dig too deep on that because I don't want to confuse everybody like me who doesn't get down to the details. But hopefully a developer will understand that. And if not, there is more to break out on it. Now there has been some mobile development on the Safe Network previously. Could you lay out what was done there and why what we're doing now is different? I guess that's a matter of understanding what is a native application and what was being done before.
Yes, John. So previously, in the early stages of Alpha 2, we came up with a proof of concept that you can access the safe network through a mobile device. And through this, there was a safe authenticator proof of concept and also a safe messages kind of application. So these two applications were built using C# through the Xamarin
C is a programming language, C#. Okay, good.
Mm-hmm. So you could use the Xamarin framework to build cross-platform applications.
Okay, for us ignorant folks, could you tell us what that means? What's the Xamarin application?
So Xamarin is a platform where you could build cross-platform applications. By cross-platform, I mean you write a single code, and that code will run on different platforms. Like so let's take mobile for example. I would write a mobile Xamarin application, and this would run both on Android and iOS. So when I write the code, I will not write it for Android or iOS. I will write it for Xamarin, and Xamarin will translate it to Android on Android devices and to iOS for iOS devices.
Okay, so Xamarin then is kind of an in and out interpreter that stands between whatever, I mean, it interprets for whatever platform it's interfacing with.
Yes, exactly.
What is the disadvantage of that as opposed to a native application?
Well, although Xamarin has the advantage of being cross-platform and you can share code between Android and iOS platforms, it doesn't give the developer much flexibility in terms of the native APIs that are provided by the platform. But if you use native code, you have much more flexibility. And Xamarin, again, it's something intermediate which will translate the code you've written into the native code that is expected by the device. So again, the application size is going to be a little bigger, the performance is not going to be as much, and as I said before, the flexibility of the developer is limited.
I got it. Okay, good. So let's talk about what is a native application and why, in terms of we've got native to Android. That's going to be different than you're going to have to write a different one for iOS, right?
Yes.
Okay. So right now we're talking about Android development, but that's not too hard to change over then to iOS later, right? Or is it a really different project?
Yeah, it would be a different project for it because the native development for Android and iOS are not supported by the same development languages.
Oh, I got it.
Android expects Java or Kotlin, whereas iOS they expect Objective-C or Swift.
Okay, so they're just different languages, but you could have the kind of the logarithms, the basic plan of the thing, and then just translate one language to another without too much problem, probably.
Yeah, it really isn't much because anyways, the Safe Network is using common code that is written in Rust, and this code is compiled for various platforms. So the only thing left to do would be generating bindings that would be able to interpret this common code to platform code.
I got it. Okay, well, I don't want to get too deep into the weeds there, but I follow my own curiosities as we go. Okay, so basically, as I understand it, the toolkit you've developed is for application developers to develop native code for Android applications. And that's neat because it's more flexible and faster and lighter weight. And is that pretty much cover that? Am I feeding back to you?
Yes, John, and not only that, there are more native developers rather than cross-platform developers for a particular platform. For example, if I were a mobile developer who develops on Android, the probability that I would be comfortable developing using Java or Kotlin using the native development environment is so much more than more than Xamarin developers. So native developers are all larger in number because of the flexibility that they have for development.
Oh, I got it. Not everybody likes to use that cross-platform because of limitations and flexibility and so forth. I got it.
Applications that want to scale, like largely scaling applications, are mostly written in native code. And when people pick Xamarin like platforms for cross-platform development, when the team size is minimum. For example, even MaidSafe, when we developed the proof of concept for the Safe Authenticator, we used Xamarin as a platform because we had a limited team. So we wrote one code that would run on Android and iOS.
So I got it. That's great. What do we need to know about this development package for developers on Android?
So what we've released to enable native Android application development is an Android library that developers can include into their Android application project. And this library will have all the APIs that a developer needs to interact with the safe network. And this library is available for both mock and non-mock.
Yeah, that is something we need to break out, is the difference between mock and non-mock. So before we go there, let me just feedback, make sure I understand what you're saying. There's a whole set of program libraries that are enabled and exposed in the application program interfaces, the APIs that the Safe Network has provided, and that are being provided for user interface for the different languages that the apps use. So that gives the developer all the tools he needs to do various things as long as he understands what the network is. And then we get into documentation on bringing somebody up to speed, and we'll talk about that in a minute. Okay, so mock routing. Well, what is mock routing as opposed to actually integrating with the network, and why is that important?
Well, mock routing is a feature that we've introduced to enable developers to test the application while they're building it within their system itself. So if I say that my application is running on mock routing, it means my application is not working on the decentralized network, but rather the network is mocked on a single file which resides within the system. And all the data that is transferred between the application and the network goes to that file. So it behaves exactly the same as the network itself, but it gives the developer the flexibility to try it out before he actually connects it to the network.
So it's just a system that says if you put in this kind of input, you're going to get this kind of output. And so if you don't, then there's something wrong with your code. It's not going to run on the network, but if it works within the mock routing, it should work on the real network, right?
Yes, exactly.
Okay, so yeah, I can see how that could be much more agile.
Yes, and if you were to develop on the network itself, currently you will be needing to use up all your puts. So in this case, you can save them for when you actually put it onto the network.
Oh, I got it. So just for those that need interpretation of what you mean by saving or by using up all your puts, when the Safe Network is live and so forth, it will cost something to actually store data on the network, to actually put data to the network, and it'll be relatively cheap, but it will still require some interaction with SafeCoin. And in the test networks, just as because of development and so forth, we don't have SafeCoin introduced, and so we have a permission to network. And once you get a token to join the network, you get a certain amount of ability to put data onto the network. And if a developer was using that, they just have to keep getting extra tokens to do that. When it's not necessary, you can just use mock routing, right?
Yeah, exactly.
Okay. What else do we need to know? What's the features of developing an application for the Safe Network? What does that enable that you can't get anywhere else currently? There is no way to interface a decentralized network in this fashion. Is that fairly correct? I mean, I don't know of any myself. Do you?
Yes, John, something like that. So by using what we've extended is we've allowed native developers to now do whatever the Safe Network can do. So any application that currently works on the Safe browser or on your desktop, so whatever it does, you can make a mobile application do the same.
Cool. So I guess I see where we need to go now. What has been provided in terms of the package you've got? You've got the APIs are exposed, and there's some development tools and some examples. Let's go there. So developers can kind of know what to expect, and other people can have confidence that somebody's taking care of it. I fit in that class. But so what is this package you guys are really putting out?
So along with these two libraries, we've also put out an example tutorial application which demonstrates how you can use the library in an application of your own. So we built a very simple to-do list application where you can add, update, and delete data on the network.
Very simple, but that's the basic. That's kind of the basic functions of any application, right?
Yeah, exactly. But we've shown them how you can build up an authentication request, send it to the authenticator, get the response back, so connect to the network, and then perform all these operations. So these are the basic operations that are done before you start sending and receiving data from the network. So we've demonstrated all these in that simple application.
Cool. What other things are you guys providing that makes the path easier?
So along with the code of the application that's available on GitHub, we have a step-by-step tutorial which explains each and every line that says, okay, we're going to send a request to the authenticator. This is how you do it. These are the API calls that you need. And so basically the step-by-step process which the developer can follow and build the application that we've shown them. We said, okay, this is the tutorial application and this is how you build it. So it guides them in a step-by-step process, which helps them build that example application. And once at the end of the tutorial, they will be able to know, hey, now I can insert, read, and update, delete data on the network. And they can use that knowledge to build applications of their own.
So, to what level of developer are we talking here? Are we talking about only someone who is really seasoned, who really knows their stuff, or is this something that, hey, I don't know much about this, but I'd really like to learn? What would their curve be in terms of wading into this?
Well, you need to know how to basically build an Android application, but you need not be very experienced to follow this tutorial because we've provided a boilerplate. Say basically this is the code that you need for the application to run, but it doesn't include the safe network operations. So we've explained the safe network operations and we said this is the operation that needs to go here and this is the application that needs to go in a different place. So the application for the code for the application is already there. They just need to add the safe network operations to it. So even new developers can try it out.
Cool. And I guess the last thing we haven't really covered is, say a wallet application for Bitcoin and Ethereum. They set up and they maintain the interface with the network, and they give and get data and so forth, and takes transfers. They usually take some kind of small percentage of the action, and that makes it worth having the application and so forth. What is the motivation for somebody to develop an app on a network such as this? You can't get in between the user and the network. Why would an app developer want to do that? Is it just because it's cool, or is there a profit potential in this?
So the Safe Network has something called pay the producer, because over here on the Safe Network, so people who store data are being paid because on the Safe Network, if you run a vault, you're giving your systems resources, and in the process, you're getting paid in Safecoin. In the same way, the application is the reason why this data is there. If, let's say, I build an application which people use to upload videos and other people watch videos. So it's because of my application that so much data is being transmitted across the network. So I am the producer of that data. So there is a certain percentage that will come to me because I am the producer of that much data. So developers can earn money, in this case, Safecoin, by developing good applications for the network.
Well, cool. Is there anything else that we need to cover before we break down where people ought to go if they want to find different stuff? Well, I'll put all the links in the show notes as to where people should go and why and so forth. But is there anything else about what you're doing about this Android native development that people ought to know about that we haven't covered?
Well, the tutorial covers only the basic operations that is needed to send and receive data on the network. And let's say a developer wants to do something beyond that. There, the developer can go to the API documentation, where we've clearly explained all the APIs that we've exposed, every function, what it requires, and what we have to pass to the function and what you get back. So developers who have already built the basic application via the tutorial can go ahead and developed even more complex applications by referring the API documentation.
Oh, right. We didn't really talk about the API documentation is quite thorough, as opposed to the example documentation that you guys are doing on this, which is more introductory, right?
Yes, exactly. It just gives you an introduction, something where you can get started. And once you get started, you keep moving through the API documentation.
Very cool. And there's a good developer community. There's hub.safedev.org, which is a good place for developers interested to start. And there's a forum.safedev.org for developers to congregate and share. And for the broader community, there's safenetforum.org. That's where everybody can get together and share ideas and thoughts and questions and discoveries. Anything else we want to cover here?
Perhaps you want to touch up a little bit more on the Safe Authenticator proof of concept?
Oh, yeah. Well, yeah, please do. Please do. I'm not trying to brush things aside. Tell us what you have in mind there.
So previously we spoke about mock routing and how a developer can test the application during the development process within his device itself.
Right.
So once you're ready for your application to go to the Alpha 2 network, then you can download the Safe Authenticator proof of concept from GitHub. And through the Safe Authenticator, you can authenticate your application, which can now send and receive data to the Alpha 2 network.
Cool. And that's going to that app will hopefully before too long be on the Google Play, right, for the Authenticator?
Yes, John, the team is currently working on that. So currently it's just a proof of concept to show that your mobile device can actually authenticate and connect to the network. So the guys are working on improvements, enhanced user experience and stuff. So once all that is ready, we're looking to put it forward to the Play Store soon.
Cool. And then iOS will follow along in due course, hopefully not too long, right?
Yeah,
because there's a lot of iOS developers out there.
Actually, the Play Store and iOS releases are going to go hand in hand. They'll be in the same time.
Good. Cheers. This is about Android native development. I assume there'll be documentation following for iOS down the line, prior to the Authenticator release. Okay.
Currently, we have the C# package that developers can use to build Xamarin applications, which do run on iOS.
Okay, so they can do the Xamarin ones. Right.
Yeah, exactly. They can use Xamarin, and API documentation is available for that.
Good. So we'll see how all that rolls out. Well, Lionel, thank you so much. I've enjoyed it. I actually learned a lot in our previous discussion and so forth. That it's a lot of stuff and perspectives I didn't know, and hopefully we've shared some of those things for both developers and those that are more ignorant like myself. It's neat and important stuff.
It's been a real pleasure, John. Thank you so much for having me.
Good deal. The music for the Safe Crossroads is generated soup to nuts from creation, performance, and production by Nicholas Koteskey of Two-Faced Heroes. Really, really appreciate it, Nick.